Now let's discuss broadcasting in practice. Broadcasting operations form the core of many examples we'll see throughout this course. We'll now take a look at a couple of simple examples of what they can be useful. The first one is centering an array. So in the previous lectures, we saw that ufuncs allow a Numpy user to remove the need to explicitly write slow Python loops. Broadcasting extends this ability. One commonly seen example is centering an array of data. Imagine you have an array of data of 10 observations, each of which consists of 3 values. Using the standard convention, you can see later on in data representation in scikit-learn, we'll store this in a 10 by 3 array. X is equals to np dot random Okay, so we can compute the mean of each feature using the mean aggregate across the first dimension. And we got the answer this, which is x mean is equals to x dot mean 0 and x mean. So, and now we can enter the x array by subtracting this mean. This is a broadcasting operation. X underscore centered equals to x mean. To double check that we have done this correctly, we can check that the centered array has near 0 mean. X underscore now we have double checked, then we got the answer. So to within machine precision, the mean is now 0. So now let's discuss plotting a two-dimensional function. One place that broadcasting is very useful is in displaying images based on two-dimensional functions. If you want to define a function z is equals to fxy, broadcasting can be used to compute the function across the grid. Starting it off, writing a comment. X and y have 50 steps from 0 to 5. X is equals to np dot 0, 5, 50. Y is equals to 0, 5, 50. np dot z is equals to np dot sine double asterisk 10 np dot y. Now let's put asterisk np dot cos. We have an error here. Now let's look at the error. Space is not defined. We skipped np. Okay, so we will use matplotlib to plot this two-dimensional array. And now let's use the matplotlib. Import matplotlib plt aim show z origin extent 5 see map, Redis, plt dot color bar. So now we can see a graph. The result shown here is a compelling visualization of the two-dimensional function, a visualization of the 2D array. So now let's discuss comparison masks and Boolean logic.